Hello everyone, my name is Seena Patel and I'm going to give a review about Chapter 3 Essential Process Modeling. So, first, I will go over the essential concept of the process models, such as how they relate to the process intensives. Following that, I will go through branching and merging in the process models. Then, I will demonstrate how to model business items and resources in the process. Finally, we will learn how to employ sub-processes to simplify the model and how to reuse the sub-process models across the several process models. So the first topic is first step with BPMN. The essential ingredients of process modeling using the BPMN language will be covered in this chapter. The three most basic concepts of the BPMN are events, activity, and arcs. Events are represented by the circles, activities are represented by the rectangles, and arcs, basically called sequence flow in the BPMN, are represented by the arrows. The two events are illustrated with two significantly different symbols. As we can see in the figure, the thin border circles are captured start events and the thick border circles are captured and end events. Each activity should have labels. For the activity, label should begin with the verb, and for the event, label should begin with a noun. In a BPMN, the figure depicts a simple sequence of activities for modeling an order to cash process. When a customer places a purchase order, the process starts. The confirmation of the order is the first action to be taken. Next, the shipping address is received, allowing the product to be delivered to the customer. Afterwards, when the invoice is sent and once the payment is received, then the order is saved and the process is completed. So the second topic is branching and merging. To model this process, we start with a decision activity, namely checked invoice for mismatching with the following start event invoice received. There are three sequence flow will emanate from this gateway. One, towards the activity post invoice, which is performed if there are no mismatches. The another word, resend invoice to customer if there are mismatches, which can be corrected, and a third flows towards the block invoice if mismatches exist but cannot be corrected. When using XOR split, make sure each outgoing sequence flow is annotated with a label capturing. In our example, invoice can either be corrected or contain mismatches which can be fixed or mismatches which cannot be fixed. Only one of these condition is true for the invoice will received. We complete this process model with an end event named invoice handled. Make sure to always complete a process model with an end event. Parallel execution and gateways. The parallel gateways is used to model this particular relation. Especially we used an AND split to model the parallel execution of two or more branches and AND join to synchronize the execution of two or more parallel branches. An AND gateway is depicted as a diamond with a plus mark. Let's consider the following example of the security check at airport from the book. The process consists of four activities. It starts with activity proceed security check and end events with the activity proceed to departure level. These two activities have clear order dependency. A passenger can only go through the departure level after undergoing the required security check. After first activity and before last activity, we need to perform activities which can be executed in order. For example, pass personal security screening and pass luggage screening, and split the token coming from the activity proceed to security check into two tokens. Each of these tokens independently flows through one of two branches. This means that when we reach an end split, if the token is on the arc release from the activity pass luggage screening and the another token is the same color on the arc incident to the activity pass personal security screening, this indicates an intent of the security process where a passenger has just passed the luggage screening but not yet started the personal security screening. The end join of example waits for a token to arrive from each of two incoming arcs. Once they are all available, it merges the tokens back into one. This behavior of waiting for a number of tokens to arrive and then merging the tokens into one is called synchronization. Inclusive or inclusive decision take one or several branches depending on conditions. Inclusive merge proceed when all active incoming branches have completed. Rework and repetition. To model rework and repetition, we first need to identify the activity or more in general the fragment of the process that can be repeated. In our example, this consists of the sequence of activity, prepare ministerial responses and review ministerial responses. The decision activity is review ministerial responses and its outcome are response approved. In this case, we continue with the process and response not approved, we can go back. To model this outcome, we use XOR split with the two outgoing branches. We use an XOR join to reconnect the branch to the point of the process model just before the repetition block. In the Treasury Minister's office, once a ministerial inquiry has been received, it is a first registered into the system. Secondly, the inquiry is investigated so that the ministerial response can be captured. The finalization of the response include the preparation of the response itself by the cabinet officer and the review of the response by the principal registrar. If the registrar does not approve the response, the letter needs to be prepared again by the cabinet officer for the review and the process finish only once the response has been approved. Third, business objects. The business object perspective indicates which business objects like documents, file, materials are required to be perform an activity and which one of are produced as a result of a performing activities. These aspects are captured by the difference process modeling perspectives. So the question is, do data object affect the token flow? So the answer is input data object are required for an activity to be executed, even if the token is available on the incoming arcs of the activity, the latter cannot be executed until all the input data objects are also available. A data object is available if it has been created as a result of completing a preceding activity or because it is an input to the whole process. Output data objects only affect the token flow indirectly. So the second question is, do we always need to model the data object? What do you think, guys? So the data object helps reader to understand the flow of information and material from one activity to another. How, however, the process to pay is increased explicitly of the diagram. Resources. Resources is a generic term to refer to anyone or anything involved in the performance of the process activity. A resource can be a process participant, for example, an individual person like me or you or anyone else, a software system, from example, a server or a software application, a piece of equipment such as a printer, any machine, manufacturing plant, anything. So the active resources that can perform an activity, and passive resources that are merely involved in the performance of an activity. For example, photocopier is used by participant to make photocopy of a document, but it is the participant who performs the photocopying activity. So the photocopier is the resource, passive resource, while the participant is an active resource. BPMN provides two constructs to model resources aspects. First, pools, and second, lanes. Pools are generally used to model resource classes. Lanes are used to partition to a pool into subclasses or any single resources. There are no constraints as to what specific resource type a pool or lane should model. Modeling a pool as a white box or as a black box is a matter of relevance. Lanes can be nested within each other in a multiple levels. For example, if we need to model both the department and the roles within that department, we can use one outer lane for the department and one inner lane for each role. In order to cache example, we nest a lane within a warehouse and distribution to represent the ERP system within that department. Pool and lanes are depicted as a rectangle within which can be placed activities, events, gateways, and data objects. Typically, we model these rectangles horizontally, though modeling them vertically is also possible. In order to cache example, we used pool to represent business parties and lanes to represent the departments and system within the sales organization. This is because we wanted to focus on the interaction between the seller and the customer and the other two suppliers. Process decomposition. As we tackle more complex business process, we will undoubtedly produce a larger models. For example, models with many elements. To use a sub-process, we first need to identify the group of related activities. In our order to cache example, as we can see that the activities check raw material is available and a purchase raw material from a supplier lead together to purchase raw material. So these activities and their connecting gateways can be encapsulated in a process, in a sub-process. Similarly, two parallel branches for the shipping and invoicing the order can be grouped under another sub-process activity called ship and invoice. This figure illustrates the resulting model where the above activities have been enclosed in two sub-process activities. We represent such activities with a larger rounded box. As we can observe the figure, we also added a start event and an end event inside each sub-process activity to indicate when the sub-process starts and completes. When should we decompose a process model into sub-processes? We should use sub-processes whenever a model becomes so large that it becomes hard to understand. As a rule of thumb, we suggest to decompose a process model into multiple ones if the model has more than 30 flow objects by reducing the size of the models. Process model reuse. We may need to reuse components of existing process models from the same organization when the designing a processes. For example, loan provider may reuse the sub-processes for signing a loans contained in the home loan disbursement for other type of loans, such as process for distributing student loans or motor loans. By describing a sub-process as a global process model in a BPMN, we may define the content of the sub-process outside of its parent's process. This is an example of process model reuse. The process model for distributing students' loan invokes the same model for signing loans by the process for distributing home loans via call activity. So that's it. If you have any questions, feel free to drop it. And thank you so much. Thank you very much.